This is section 1.2 of geometry, points, lines, and planes. These are the fundamental elements of geometry. This is where we start the course. So a point, it's pretty intuitive. It looks like a dot, that's how we represent it. The formal definition is that it is a single location in space. It technically has no size, it's infinitely small. And we name it with a single capital letter. So a line is also pretty intuitive. We all know what a line is. The formal definition is that it is infinite in length. It's never ending. It goes on forever and ever in two directions. And we name it with 2 points, which we described above. So an example, how do we name the line shown here? Well, there's many ways we could name it. We just need to name it with any 2 points on the line. And we use this notation right here with a line above the 2 letters and a double arrow on either side. That's the notation that we use for a line. So I could call this line GS. I could call it line SG. I could call it line SR, line RS, line GR, or line RG. And if I had more points on this line, there would be even more ways that I could name it. So, what does the word collinear mean? 2 points are collinear, so 2 or more points are collinear if they are on the same line. So these 3 points up here, G, S, and R, would be considered collinear points because they are on the same line. 3 non-collinear points, so non-collinear would mean that they are not on the same line. So if I had 3 points like this, those would be non-collinear. Those always form a triangle. So using this diagram at the right, we want to do all of the following. So first, name the point that is collinear with A and Q. Well, if I look at A and Q and then I continue on that line, I see that point T is also on that same line. Name the point that's collinear with S and Q. Oops, lost my letters here. These are supposed to be S and W. So the point that is collinear with S and Q would be W. Are W and T collinear? Well, our first glance tells us no, because there's no line connecting W and T. But in fact, any 2 points anywhere in space could be considered collinear because we can draw a line through any 2 points. So the answer to that would be yes, those are collinear, even though there's no line drawn through them on the diagram. I could draw a line through those. Name 3 non-collinear points. Well, this could be a number of answers. Let's just pick 3 points that look like they would form a triangle. Those would be non-collinear. So I'm going to say S, W, and X. And then 3 other non-collinear points. Let's go with A, N, and Q. So 2 other new concepts. A plane. A plane is an infinitely large flat surface. It's kind of hard to get a grasp on what it is at first, but you'll get the hang of it. So a plane is an infinitely large flat surface. We name it with at least 3 points. We could name it with more, but we need at least 3 points to name a plane. So coplanar, just like collinear, coplanar means points or lines that are on the same plane. So examples down here to see what we're talking about. We have a 3D figure here, a 3D box. So technically there are 6 planes in this box. There's a front, a back, a top and a bottom, and a left and a right side. So why is plane ETH, so if I were to say plane ETH, why would that not be an acceptable name for the top plane? Well, we said that we need 3 points to name a plane, and these 3 points, ET and H, are all on the top of the box. But the reason that would not be an acceptable name is because E, T, and H are collinear. So since they're collinear, I could be talking about the top of the box, or I could be talking about the front of the box, since those 3 points also lie on the front of the box. So we need 3 non-collinear points to name a plane. So if I were to name the top plane using not those 3 points, because we just described why we can't use those, so I could pick any other 3 non-collinear points on the top of the box. So I'm going to pick S, E, and T. I could call that plane SET. Next question, name all the points that are coplanar with E, F, and T. Well, E, F, and T are all on the front of the box, so I need to look at all the other points that are on the front of the box. So I've got H, K, and J. Those are all on the front of the box. So those are coplanar with E, F, and T. They all lie on the front plane of the box. Name all the points that are not on plane G, J, N. So that is the right side of the box, so I need to name everything that is not on that side of the box, that's not touching the right side of the box. So that would be K, T, E, F, and S. All those points are not touching that plane. Name all the points that are not on plane S, T, W. Well, S, T, and W are all on the top of the box, so that means I'm naming that top plane. So I need to name all the points that are not touching the top plane. So that would be F, K, J, and N. Just an important concept here while we're talking about planes. When a plane and a line that is not directly on the plane intersect, they meet at a point. So if I were to take my pencil and drop it onto my piece of paper could represent a plane. If I were to meet my pencil with my paper, my pencil would meet my paper at one single point. So a line and a plane meet at a point. Next page, so more about planes and intersections of lines and planes. Using the 3D solid, what's the intersection of line NY and plane WKS? Well, WKS is the top of this box here, and line NY is going up and down vertically right here. So the intersection of that line with that plane, this line is not on this plane, so as we just described before, this line and this plane must meet at one single point. Well, if I look at this line going up and down right here, and this plane, the single point where those two things are meeting is point A, this corner of the box right here. Those two things are meeting at point A. What's the intersection of line HL and plane AKR? So AKR is the front side of the box, and line HL is this line over here. So again, where does this line meet the front of the box? Well, it meets the front of the box at this corner right here, P. Those two things meet at point P. What's the intersection of line PH, which is the same line we were just talking about, it's just a different way of naming it, as we talked about before. What's the intersection of that line with plane WLS? So WLS is kind of hard to see. Those 3 points are actually on the back of the box. So that line right there is actually meeting the back of the box at point L. Name 4 different lines that are coplanar with NY. Coplanar meaning that they are on the same plane. So this is a little bit difficult here because we don't really have too many lines drawn in, but remember that we can draw a line through any 2 points. So coplanar with NY, well, NY is actually part of the front of the box, and it's also part of this side of the box that we can't really see. It's going 2 different ways. So we could name any lines that are on either of those 2 planes. Well, this line right here is also on the side of the box, line AW. We need 3 more, so we said it's also part of the front of the box, so I could name this line right here, AK. I could name this line right here, RP. And I could name this line right here, PK. So we talked about when a plane and a line meet, when two different planes meet, as we see here. So we see a lot of different instances of planes meeting in this box figure right here. When two different planes meet, they actually meet along one single line. And we'll explore that right here. So using this figure, again, we have another box. So where do plane FJK and plane SWG meet? Well, FJK, those 3 points are all on the front of the box, and SWG, those 3 points are all on the top of the box. So basically I want to know what line, because I know that two planes, always intersect in one line. So I want to know what line goes through the top of the box and the front of the box. Well, this line right here is at the top of the front or the front of the top, whichever way you want to think about it. So line EH, or I could also use point T to name that line, but remember, only use 2 points to name a line, 3 points to name a plane. So line EH would be going through both of those planes. That's the intersection of those two planes. Next one, GNW. GNW is the right side of the box, and ETF is the front of the box. So we're looking for the right side of the front or the front of the right side, which would be this line right here, HJ. That's where those two planes are meeting. Next one, plane SET, which is the top of the box, and GJN. Oops, I covered up my J down here. So GJN, which is the right side of the box. So the top and the right, I'm looking for the right side of the top or the top of the right side. So HW. Last one, plane FJN and plane SWH. So FJN is actually the bottom of the box, and SWH is the top of the box. So we're looking for the intersection of the top and the bottom of the box. Well, top and the bottom of the box are actually never going to meet. They are going to be parallel to each other, a concept that we'll explore later. So there's actually no intersection of those two planes. They're never going to touch each other. All right, so next, concept of a line segment. So a line segment is really just a piece of a line. It has two endpoints, and it has a certain length. Unlike a line, we can't measure a line because it's never ending, it goes on forever, but a line segment we can measure. It has a definite length. So, ways to name segments. We name them in a similar way that we name lines, except for a line, we draw two arrows on the top of our line symbol. For a line segment, we don't draw those arrows to show that it is a line segment and that it ends. It doesn't keep going like a line. So one segment that we have here is RU, so that's segment 1. Segment 2 is this segment right here, so that would be called UT. And the third segment is going all the way from here to here. We would call that segment RT. And again, just like a line, you could also call this UR. You could also call it TU. You could also call it TR. Doesn't matter what order you use the points in. However, a ray is something where it is going to matter what order we name it in. So a ray is sort of like half of a line. A ray has one endpoint, and goes forever in one direction. So what do I mean by that? Well, down here we have some examples of rays. So a ray is kind of a combination of a line segment and a line. So it has one endpoint, and then it goes forever in just a single direction. A line goes forever in two directions. A ray starts at a certain point and then goes forever in one direction. So just like a line, we can't measure a ray. It does not have a definite length, but it does have one endpoint, kind of like a line segment. So the way we name this is we have to name that endpoint first. So for this ray, I would have to put point P first and then another point on the ray. So I would call this ray PA, and like a line or like a line segment, I have to put this symbol above it to tell what I'm talking about. So for array, we start with a line segment, and then we draw one arrow towards the point where, in the direction that it is continuing. So for this one, I could either call this WD, or I could call it WG. But I have to use W as my first point because that's where it's starting. For this one, I've got two different rays. So I've got ray ND, and I've got ray NR. So opposite rays, what are opposite rays? Opposite rays have the same starting point, and they go in exact opposite directions. So an example of what I'm talking about, it says draw each of the following opposite rays SQ and SR. We can see that both of these rays are starting at point S, so I'm going to draw a point S right here. SQ would mean a ray going one way, and SR, if these are opposite rays, I have to go the exact opposite way and draw ray SR. Non-opposite rays could be rays that still start at the same point, so both of these rays start at point W. But if I draw this ray going this way, and this ray going, it's still starting at W, but it's not going the exact opposite direction, then these would be non-opposite rays. Rays GT and TH, so this one starts at G, goes through T, and then keeps going. This one starts at T and goes through H, so I could draw point H here, or I could start a new ray and draw point H here. Either way, that would work. Last example, draw three non-collinear points, A, B, and C. So non-collinear points, A, B, and C. Then draw line AC. So line means that it goes forever in both directions, so I have to draw an arrow on either end. Ray BA means that I have a ray starting at B, going through A, and then continuing. And ray CB means that I have a ray starting at C, going through B, and then continuing.